Hello, my name is William Wasson and welcome to my MEC3027 assignment. So starting off with the basic layout, we have two tracks with a motor powering each. We have a master Arduino in the middle, an LDR on the top, two batteries for the power supply, a magnetometer and a slave Arduino towards the back. We then have three ultrasonic sensors, one facing forwards and one left and right, and then a bumper with a micro switch on. So now running through my list, the first rule that I wanted to get done was stop collisions with an object. That is done through the micro switch at the front, which when the simulation is running, you'll see that automatically the fifth value is an A. However, once the micro switch is compressed, it turns into a B. This then follows through on this side where if there is a collision, it activates all this, which stops the main calculations from occurring, wrong one, and then allows for the collision escape conditions to occur. These effectively come out of here and they have preset values that can run off, or it can just continue with the equation. This can also be seen quite well with the front panel, which if we have it set to automatic mode. With this setup, there has already been a collision. As you can see, the collision light is currently turned on. To show you what it's like without, there's angular velocities going through, the collision lights turn off. Turn the collision lights on. It turns off the angular momentum and it waits for you to select an option. If you do continue, it just goes back to where it was at before, continues operating normally, and then there's a few different options that basically override it with different options. So just showing off when we have a collision, the options are, it starts off with a select option with the velocity at 0. Once you select it, you can do continue, which just continues on as it was. Reverse, straight, and they go on, and they basically just have preset values that you can control and do slightly different things with. Now next up is using the sensors for moving around. So we have the sensor for direction in the potentiometer, which is the magnetometer, and then the three ultrasonic sensors. Now as these change, you can see the serial monitor also changes, and then these can be inputted into here. Now, so there we go, I've just entered the values there that we had just got, and as you can see there's no longer a collision. There is a squirrel on it, so it's detected a squirrel and it's added one to that, and as things are pretty open with where these are, pretty far out, it's going into fairly high velocity. Now, showing this in here, we have, it comes through, does the calculations and such, and then we have the fuzzy controller in here, which is set up in this configuration. It's a MIMO configuration as well, and there's 27 rules about avoiding objects and 3 about turning, and these have a degree support of 0.7 as not hitting something is more important. Now coming through, this is basically just for the few cases where it's stop. This means that it is actually moving and it can then find new combinations, so it can then move off. So next set of rules are that the objects get detected to the front, left and right of the vehicle, and additionally uses the magnometer to detect the direction of the vehicle and adjusts its head in the due south direction. Now, actually starting off in the Tinkercad, we have our 3 sensors, which as they're adjusted, you'll see the first 3 values change accordingly. calculations for this are seen here with 3 different sensors. The magnetometer, that works off this bit of code here, and effectively that just detects the direction and then ships that out in the string to the lab view, where once it's in lab view they come in and they're calculated, and then these go into the fuzzy controller here, where the calculations are performed with this setup. And there's 30 rules overall. 27 of them are for avoiding objects, and the last 3 are just for heading in a southerly direction. Yeah, so then these values come out, they skip over this unless there's been a collision. They come out and they're transformed back into a string. Now, the way I've chosen to do it is I've done a string with a positive and a negative, a uppercase and a lowercase letter. I just find it clearer and more recognizable in the programming. So that can be put back into here as 2828. It just so happens that they're the same. But if we were to just pick some random different ones, it would also work just as well. So the next thing is using the LDR to detect the squirrels, and using hysteresis setup to prevent double triggering and so on, and also having a way to reset the counter. So this is done with the ambient light sensor here, where obviously once it's at max, you'll see down in the serial monitor it changes to an A, because that's maximum light, so there's nothing on there, and then B, because there is something on there, it changes. Now in the code, that's here, so that just runs fairly simply. Some fairly simple code. Now in here there is another layer to prevent double triggering, where the code has to come in. If the value is true, that there is a squirrel on top, it will add 1 to the count, and then once after 10 milliseconds, it will then move on to the next step, which is basically waiting for them to get off. Once they're off, it will wait an extra 5 seconds, and then it will repeat that again. So with those things combined, I feel like it's a fairly robust system. Additionally, I want to mention up here we have the reset circuit. So very simple, just setting things to 0, which can be seen on the front panel here. So obviously at the minute it's 0, but if we change the value here to an A, and then we have to wait 5 seconds for the code to run through, then we can do it and it'll show a squirrel. Again, there you go. And then the reset button very simply works. Just a click, it sends it back to 0. So next up is adding values in a spreadsheet, which can be seen here. They're added there and can be seen in this spreadsheet here. These are then used for the calculations, primarily for the manual override. Now moving on to the next, we have the manual override itself, as well as RPM restrictions and a velocity start-stop. The velocity start-stop is seen here, and that is just simply for if you wanted to still count squirrels but be stopped. And then the override for manual is done using this switch here, switching to manual, and then you can use the rotation controls and the forward controls. There you go, and that changes your string there. And this is for stopping you from basically burning out your motors, as we've calculated what the maximum RPM should be, and it basically just enforces that there. Finally, we have communicated through Tinkercad, which we've already done, and then the check case, which is just the final digit here. We add them all up, divide by 6, and I've done one either side due to rounding errors, and it will tell you if you've got a transfer error. As I'm running out of time, I'm just going to quickly mention that I did try to make a slave controller, as you can also see it in here. However, I couldn't quite get that to work, but I did have a go. Any other questions or anything that I can help out with, please let me know. Thank you very much.